One of Russia's key air defense assets is the Pantsir family of short-range air defense systems. The Pantsir has become one of the most important tactical air defense systems in the Russian armed forces because it fills a critical capability gap that long-range systems such as the S-300, S-400, and S-500 are not designed to address. As part of Russia's layered integrated air defense system, the Pantsir is optimized to intercept low-altitude, short-range threats. However, a growing number of incidents have raised questions about the Pantsir-S1's effectiveness against modern drone threats. One notable example is the repeated targeting of the Moscow Oil Refinery in Kapotnya. Despite the deployment of multiple Pantsir-S1 systems following earlier attacks, the facility was struck again by Ukrainian drones, resulting in another fire. In this video, Defense Updates analyzes how Russian Pantsir-S1 has been exposed so badly. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The Pantsir-S1 is the first operational and most widely produced member of the Pantsir family of air defense systems. It is a self-propelled short to medium-range surface-to-air missile and gun system designed to provide point defense for military installations, strategic infrastructure, and high-value assets against a wide range of aerial threats, including fixed-wing aircraft, helicopters, precision-guided munitions, cruise missiles, and unmanned aerial vehicles. Notably, the Pantsir-S1 is frequently deployed to protect long-range air defense assets, such as the S-400, from threats that penetrate the outer layers of Russia's integrated air defense network. The system is mounted on either a wheeled or tracked chassis, providing high tactical mobility and allowing it to accompany maneuvering ground forces or rapidly redeploy to protect critical locations. The Pantsir-S1's fire control suite integrates multiple sensors to detect, track, and engage targets under a wide range of operating conditions. Its target acquisition radar provides 360-degree coverage using a passive electronically scanned array with a detection range of up to 36 kilometers, 22 miles. Once a target is detected, a dual-band UHF-EHF tracking radar can maintain a track at distances of up to 28 kilometers, 17 miles against a target with a radar cross-section of approximately 2 square meters. The system is also equipped with an electro-optical targeting system featuring an infrared channel, enabling target detection and engagement in environments where radar performance may be degraded, such as during electronic warfare or poor weather. A defining characteristic of the Pantsir-S1 is its integration of both guided missiles and rapid-fire cannons on a single combat vehicle. This combination allows the system to engage targets across different ranges while providing multiple layers of defense against saturation attacks. Its primary interceptor is the 95YA6 surface-to-air missile, while the export variant is designated 57E6. The two-stage, solid-fuel missile uses radio command guidance and is carried in 12 sealed launch canisters arranged in 2 banks of 6 on either side of the turret. The missile has an engagement range of up to 20 kilometers, 12 miles, reaches speeds of approximately Mach 3.8, and is armed with a 20-kilogram, 44 pounds, high-explosive fragmentation warhead. For close-range engagements, the Pantsir-S1 employs two Tu-38 Hermes 30mm dual-barrel automatic cannons with a combined ammunition load of 1,400 rounds. Operators can select between high-explosive fragmentation and armor-piercing ammunition depending on the target. Each cannon has a maximum cyclic rate of fire of 2,500 rounds per minute, providing an exceptionally high volume of fire against fast-moving aircraft, missiles, and drones. The guns have an effective engagement range of approximately 4 kilometers, 2.5 miles. Recent Ukrainian long-range drone strikes against targets deep inside Russia, including strategic facilities in and around Moscow, demonstrate how Kyiv has steadily adapted its tactics to exploit the inherent limitations of layered air defense networks. Rather than relying on isolated UAV incursions, Ukraine increasingly conducts coordinated saturation attacks involving dozens, and in some cases hundreds of drones approaching from multiple directions. Such attacks are designed to overwhelm defensive systems through sheer volume. Even if air defenses maintain a high interception rate, a small number of penetrating drones may still be sufficient to inflict significant damage on their intended targets. Russia also faces a fundamental geographic challenge. Its vast territory and the large number of critical military, industrial, and energy facilities make it impossible to concentrate short-range air defense assets, such as the Pantsir-S1, at every potential target simultaneously. Regardless of how many systems are fielded, available assets must be prioritized, leaving gaps that can be exploited. The characteristics of Ukraine's long-range strike drones further complicate interception. Many fly at very low altitudes, follow terrain-masking flight paths, and travel at relatively slow speeds, reducing radar detection ranges and shortening engagement windows. In addition, Ukraine has increasingly employed mixed strike packages comprising propeller-driven long-range UAVs, faster jet-powered missile drones, decoy targets, and other aerial systems. This combination is intended to complicate target identification, saturate defensive radars, and increase the probability that at least some strike platforms penetrate the air defense network. Concerns over the Pantsir-S1's effectiveness against small unmanned aircraft are not new. In 2018, Viktor Murakovsky, editor-in-chief of the Russian defense magazine Arsenal of the Fatherland, publicly discussed the issue in a Facebook post following operational experience in Syria. According to Murakovsky, Pantsir-S1 crews found that the system struggled to reliably detect and track small, low-speed aerial targets such as drones. He also claimed that operators occasionally observed the radar detecting large birds near the base, while failing to consistently track the much smaller UAVs they were intended to intercept. A challenge that underscored the difficulty of engaging low RCS, slow-moving targets with existing sensor configurations. The Pantsir has compiled a mixed operational record, and its effectiveness against well-coordinated air campaigns and complex missile attacks has increasingly come under scrutiny. The system has suffered combat losses in multiple theaters, including Libya and Syria, where several units were destroyed, particularly during Israeli air operations. While some of these losses have been attributed to factors such as inadequate crew training, poor tactical deployment, or systems being caught while not in a combat-ready state, they have also highlighted potential limitations in the Pantsir-S1's sensor suite, engagement capabilities, and overall effectiveness against modern aerial threats. The ongoing war in Ukraine has further intensified this scrutiny. Beyond its battlefield consequences, the conflict has exposed vulnerabilities across several Russian weapon systems, affecting international perceptions of Russia's defense industry. Given that Russia has long ranked among the world's leading arms exporters, sustained questions about the combat performance of its flagship systems could influence future export prospects, particularly as potential buyers increasingly place greater emphasis on proven battlefield effectiveness. Air defense has traditionally been regarded as one of Russia's strongest military capabilities. However, recent combat experience suggests that even sophisticated layered air defense networks are vulnerable to evolving threats such as mass drone attacks, precision-guided munitions, electronic warfare, and saturation tactics. The Ukraine conflict has underscored that no air defense system is impenetrable and that continuous adaptation is essential to counter rapidly changing threats. The Pantsir-S1 has been one of Russia's most commercially successful air defense exports over the past 2 decades. Its combination of missile and gun armament, mobility, relatively low acquisition cost, and compatibility with layered air defense architectures has made it an attractive option for countries seeking point defense capabilities without the cost of higher-end systems such as the PATRIOT or SAMPT. However, export success is closely tied to battlefield reputation. As more operational data from recent conflicts becomes available, prospective customers are likely to evaluate the system more critically, weighing its demonstrated strengths against its exposed shortcomings. Whether these perceptions translate into reduced export demand will depend not only on the system's future combat performance, but also on Russia's ability to address the deficiencies identified through recent operational experience.